The number of eggs laid by a sample of 90 female seagulls are shown in the table. Number of eggs being the first row, and then the frequency being the second row. And we are asked to determine the mean and the standard deviation to 2 decimal places of the number of eggs laid per seagull. So guys, to get the mean, we are going to do what we call weighted averaging. Weighted averaging, we basically multiply each number of eggs by the corresponding frequency, and then add them together and divide by the total number of things, seagulls in this case, right? So let's do that. I'm going to say x bar, or the mean, right, or average, is going to be, remember it's a simple mean, right? It's going to be 1 by 15 plus 2 by 45 plus 3 by 20 plus 4 by 10. And we divide by the total frequency, which is 90. All right. And pressing this on our calculator, we should get 2.28. And that is the mean, right? So I'll just put it there. X bar is 2.28. And then now, let's get the standard deviation. All right. To get the standard deviation, we need to basically subtract the mean from each and every number of eggs. In this case, 1, 2, 3, and 4. We need to subtract the mean there and square the differences, and then multiply by how many seagulls laid that number of eggs. So basically going to multiply by the corresponding frequency. Let's do it. No? So we're gonna do it for each and every egg. No? So for egg 1, we're gonna have 1 minus 2.28, and then we square the difference. Then we multiply by the corresponding frequency, and then we do the same. 2, we minus the mean, we're doing the deviations basically, then you square, you multiply by the corresponding frequency, then we keep on doing the same. Let's see, let me just edit here. Should I add them there? No, let's do this. Let me just edit at the bottom. I'll erase after. No? So it's gonna be 3 minus the mean squared times the corresponding frequency, and then it's gonna be 4 minus the mean multiplied by the corresponding frequency, right? Then pressing this on your calculator must give you 24.576. I do 3 decimal places because it's not my final answer. My final answer is 2, so I round off more so that I don't lose the accuracy. And then the second one should give you 3.528. Let me confirm if I pressed this one properly. It's 2 minus 2 point. I don't think I pressed it properly. Let me just verify. It's always good to always verify. No? Oh yeah, it's fine. Okay. And then okay, the others, then I'll just be confident. So this one is 10.368. Then this one is 29.584. Right. Now we need to add all these values up and divide by the total number of seagulls. And that will give us what we call the variance. Ne? And to get the standard deviation, we just need to divide by we need to square root. So the variance in this case, the variance would be the sum of those numbers. So all those numbers added together give us, let me see. Okay, just putting on a calculator quickly. Okay, that should give us 68.056, and then we need to divide that by the total frequency, which is 90, and then square root both sides, right? And then the standard deviation would be 0.87, right? So the standard deviation is 0.87 eggs. This means that the number of eggs per seagull varies by about 0.87 eggs from the average, right? And then now let's look at the second question. The second question, they say, Seth noticed that the sample did not include female seagulls that laid no egg. How would the mean and the standard deviation change if these seagulls were included? Right. If we added those 0 egg laying seagulls into the mix, we need to adjust the average and the standard deviation, obviously. But let's not panic. It's not going to throw everything off too much, right? Obviously, remember the mean. It means if we add in them here, I'll just show you. The frequency will increase. Okay, I just want to show you something here on the table. Let me just select this. Let's say 5, and for example, I just want to show you 0 there. Let's say it was about how many? Let's say 20, for example. I'm sure you can see that the frequency is going to increase, but the sum is not going to change because 0 times 20 is still 0. So on top we're not changing, but at the bottom we're going to be dividing by a bigger number now. So the mean is going to decrease, right? The mean will drop slightly. And remember, if the mean gets smaller, it means our deviations are getting bigger. And if the deviations are getting bigger, it means the standard deviation would increase. So your answer here would be mean drops. If they need a reason, is because we are dividing by a bigger number now. The frequency will increase, but the sum will stay the same. And if the mean drops, the deviations gets bigger by default because it means we are subtracting by smaller mean there. So these values are going to drastically increase, automatically increasing the variance, hence the standard deviation. I hope that makes sense, ladies and gents. If this video added value, please don't forget to subscribe, share with family and friend. See you soon. Tango.